Now, it turns out the general process to make time slow down in our world is actually pretty easy. And in fact, I'll show it to you right now. We're going to go back to our main Puggle class, and we're going to jump down to our new frame listener. And basically, the trick is just looking at this step function. Right now, I'm calling the step function every frame and saying simulate the world moving, 1/30th of a second, because that's my current frame rate is 30. Now, if I want things to slow down, it's as simple as saying instead of moving 1/30th of a second every frame, I want you to simulate, say, 1/300th of a second every frame. And if I run this application, I am now moving very, very slowly. But as you can see, everything still works. Okay, this is boring. Let's go back to our application and make sure that we only slow down time when, say, we're getting very, very close to hitting our final peg. So this is probably the wrong thing to do. Now, I suppose I could do all of this functionality within my main Puggle class. I could just keep, say, a Boolean variable that's slow down, and here I could say, if slow down, then step 1 over frame rate times 5, otherwise step 1 over frame rate. However, it's actually, I think, a little easier if I push some of this functionality out into another class. So I'm going to do that. Let's create a new class that I am going to call Time Master. That sounds pretty cool. Time Master. All right. And I'm going to keep track of a little variable called frame rate. And when we initialize this function, we're going to have frame rate equal to our physevals.framerate constant. At this point, I can create another function called, let's call it getTimeStep. That will return a number, and it will return 1.0 divided by our frame rate. Now, if we jump back into our main Puggle class, I'm going to, let's create a member variable called Time Master, which will be a Time Master. We'll create a new one here. And then down in my new frame listener, instead of stepping 1 over this constant, I am going to step timemaster.getTimeStep. When I run this, it should look exactly the same because all TimeStep is returning is 1 over our frame rate constant. And in fact, that's what we're getting. So far so good, right? But at this point, it's pretty easy to create a slow down and speed up function. So I'm going to create a function called slow down. And basically at this point, I'm just going to say frame rate equals our physevals frame rate times 5. And I'll create sort of the opposite function. We'll call it, instead of speed up, I'm going to call it back to normal, which will set our frame rate back to our physevals frame rate. So hopefully you understand what's happening here. If I were to call slow down within my Time Master class, it would set frame rate now to something like, I guess instead of 30, it would set it to 150. And then when I get the time step, instead of returning 1/30th of a second, I'm going to return 1/150th of a second. And inserting the logic for slowing down and returning back to normal is easy because we've already done it for our camera. So I'm going to go back to our Puggle class and over here and check for zooming. In addition to calling our camera zoom in, we'll just call our Time Master slow down. And in addition to zooming out, I will call Time Master back to normal. And I suppose I will do it here too. Now if I hit F6 and run it, so let's see what we got here. See if I can get my ball close to this final goal peg. Looks like we're going to get there. Slowly. There we go. Not only have we zoomed in, but now time is moving much slower. And eventually, when my ball gets away from this final peg, eventually, there we go, time speeds up again. Look at that. It all works. Crazy. So that was actually easier than I thought it was going to be. This is kind of a short lesson for something that seems like such a fairly involved effect. But that's it. That's actually all you need to do. So maybe what we'll do next is a little bit of cleanup before we get to, I think, probably the last big section of our application, which is inserting the aiming line. So stay tuned for all of that fun stuff.